Hey, pre-algebra, we are back to work. Lesson 90. See, you're here on time. Wonderful. Okay, so this lesson is on sets. I want to talk to you about what elements of the set would be members of the set. So this set right here, where you start with 0, 1, 2, and then the ellipsis, dot, 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 means it goes on forever. Okay, what set is that? Oh, I hear you. Well, whole numbers, you're right, because it includes 0, which has a hole in it, right? And if we took away the 0 and we just started with 1, 2, 3, what's that set? Natural or counting. Very good, very good. Now, here's another set. You know what this one is. We want to show the ellipsis at the beginning and at the end because it goes on and on forever in both directions. This is the set of integers, right? Okay, and if we can't do the set of rationals because that's way too broad, right? It includes ratios of integers, so 22 over 7 or negative 5 over 1057 would be rational, right? So we can't illustrate that one. So anyway, these are elements of the sets, right? And we want to talk about set notation and how to illustrate these. So the first exercise is example 1, and it says use set notation. So that means you're going to use the braces. They don't have to be drawn perfectly, but you're going to illustrate the set of even integers. Okay, so if you were going to illustrate the set of even integers, you know that it goes on forever in the negative direction. You'd want to give me a couple of them, maybe -4, -2, 0, and then some positives, and then your ellipsis. Okay, so you've illustrated the set of even integers. So if you were doing the odds, you might want to do -3, 1, -1, 1, 3, 5, just a few on both sides, okay? All right, so turning the page, the next thing they teach you is the symbol. So if I said to you 4 is an element or is a member of the set of integers, is that true? Okay, so this symbol is saying this is a part of, it's a member of it, it's an element of the set. So is 4 an element of the integers? Yes, true, right? That's a true statement. Now if I made this 1/4, is that a member of the integers? No, that would be false, okay? So what I would want to do in that case is, we're not done, you're not done, we don't have 3-minute lessons. Okay, I want to put this, it's not a member of the integers, so we put the line through the little element symbol. Okay, then on example 2, it says, use set notation to indicate whether each number is an element of the set of rationals. Okay, so I'm on example 2, okay, part A. So the number 2, okay, is that a member of the rationals? Yes. Okay, you might want to shorthand it, okay, rational, rat's fine. All right, for B, 1/2, is that a member of the rationals? Yes. And then C, radical 2. Is that a member of the rationals? Oh no, that's irrational. Remember, irrationals are decimals that do not repeat and do not terminate. And radical 2 would not be a member of the rationals. Another number that wouldn't is pi, right? Or radical 10. Some numbers like that. All right, so then example 3 says to graph the elements of each set on a number line. So if we're going to graph, first of all, the set of integers on the number line, boy, I made that really crooked. You might want to show me a few, you don't have to put the plus. And you're going to put dots on a few of them, okay? At least 3. 5 is nice. And then you want to darken the arrows because this goes on forever. But I don't want a solid line. because I'm just supposed to graph on the number line the set of integers. So if I just want integers, I don't want 1/2. I don't want -2 1/3. So I just want the integers. I want dots on at least 3, and I want to do the arrows darkened because it goes on forever. Okay? All right, then next I want to plot the radicals here. Okay, well let's think about this a minute. So I'm going to put 0 and 1 and 2 and 3. So I'm graphing square root of 1. Well, isn't square root of 1 1? Okay. And square root of 4 is 2. So square root of 2 is going to be somewhere here, and square root of 3 is going to be somewhere here. Right? Square root of 9 would be at 3, so square root of 5 is going to be real close to radical 4. You get the idea, I hope. All right, then the next part of the lesson is to use this Venn diagram stuff here. We also want to show this the symbol of subset. So I first need to, they use a symbolization on page 601. They call the naturals with the N. Okay, remember those naturals and counting numbers, same thing. 1, 2, 3, 4. The integers, they use a Z. I tend to use INT. They use Q for rationals. I tend to use RAT. For irrationals, I usually just do IR. And then R's would be for the reals. Okay, so that's your symbolism. So underneath example 3, it says sets can be related to each other in various ways. If all of set A is contained in set B, then set A is a subset of set B. Okay, so do you see how they've got something there? It says rectangles are within the quadrilaterals. Okay, the set of rectangles are a subset of the set of quadrilaterals. Okay, every rectangle fits there. I could also say parallelograms are within the subset of quadrilaterals, but I couldn't say it vice versa. Not every parallelogram is a quadrilateral, right? We could have a trapezoid. All right, so then it says, example 4, it says use the subset symbols to show the relationship between the set of natural numbers and the set of integers. So I would say naturals are a subset of the integers. And if you use the letters they do, that's fine. I'll figure it out, okay? Does that make sense? Naturals are a subset of the integers. Now let's make something up that's not true. What about the wholes are a subset of the naturals? Is that true? Is every member of the whole number a subset in part of the naturals? No. 0 is a whole number and 0 is not in the naturals. So I'd have to say not a subset. Okay? All right. They show you the Venn diagrams. And I'm going to let you read over that. Okay? But the next thing I want to show you is unions and intersections. Okay, so we're going to look at example 5. Do take a moment to look at the Venn diagrams on 601. Okay, so let's say now that we have set A, which is 1, 2, 3, and 4, and set B is 2, 4, 6, and 8. Okay, so if I have this, A union B, okay, this symbol right here is union. Union tells you to put all the elements of both sets. Now you don't have to repeat them. In other words, if it's in both sets, you don't have to write it twice. So what would be the set that is the union of A and B? Well, we would need 1, 2, 3, 4. So we've got 2, we've got 4, we need 6 and 8. That's the union of both sets. Okay? Every element. And I'm not writing them twice. I don't need to do that. Now, the other that you would want to do or know is the intersection. So that's an upside down U. So here I would say the intersection. So this symbol is intersection. And it's what they have in common. So what do set A and set B have in common? 2 and 4. So 2, let me write them in order. That would look nicer, wouldn't it? It doesn't really matter. Okay, so they have that in common. All right, then lastly, you have, what if they had nothing in common? Let me make one up there and you'll see what I want you to do with that. In fact, let's just start set C, which is 7 and 9. So if I said A intersect C, do A and C have anything in common? No. So I would put the empty set symbol, okay? Empty set, 0 with the line through it. You can write the words, but you should be familiar with the symbols. And there's some symbols there on page 602 you might want to keep in your notes. All right, and then lastly you have example 6, which has the Venn diagrams. And again, I'm going to let you look over example 6. And now let's do the practice. So A through J. Stop the video, do those, and then come back. I'll be writing them up for you. All right, so I'm going to go over these. A, as you see, B and C are pretty self-explanatory. D and E should be pretty self-explanatory. And F, okay. The vowels are within the set of the alphabet, okay. For G, you want to find the intersection. So as you see, I have that. And H, and the Venn diagram, here's set G, here's set H, and what they have in common is 12. For H, trapezoids and parallelograms don't have anything in common, so we wouldn't put them together. And then for I, you have, this is your union, and J, this is your union. Notice it goes on forever, so you do have to put the ellipsis. And then let me make the Venn diagrams for I and J. All right, so we've got 10, we've got 20 and 30 and 40. For J, the Venn diagram is going to look like this: 4, 8, 12, so on, and here 2, 6, 10, and so on. All right, I hope that makes sense to you all. So reference RenWeb to see what your assignment is. Best wishes. Have a wonderful day. I miss and love you all so much.